so this is going to be our chapter 2 overview. It's only out of the Algebra 2 book. So I know the chapter 1 overview had a couple of sections out of the Math 150. This one will have fewer sections and only be out of one textbook. So what will that look like to you is just will be fewer photos of pages, hopefully even easier to keep track of, but you'll want to label things by section and page number. So I'm recording this on Tuesday, September 8th. You're supposed to watch it at the 10th, 11th, so Thursday and Friday. You got 2 days to watch it. I'm giving you 2 days, even though I think this is going to be shorter than the previous one, because technically you'll be Zooming with me for a few minutes on Thursday. So again, this is Tuesday that I'm recording it. You're taking your quizzes tomorrow on Wednesday. So you should be watching this on Thursday, September 10th, having a short Zoom with me, and then finish watching it Friday, September 11th. So the practice that you see, I'll go to it quickly. These problems should be worked out next Monday, Tuesday, and Wednesday. I'm giving you 3 days. Now, if we were in school, you would have about a day and a half. I would lecture on this one day, give you the rest of the day, and the next day. That would be it. But because we're remote and we do have that one little Zoom in there, I'm going to give you 3 days. So next Monday, Tuesday, and Wednesday, those dates are the 14th, 15th, and 16th. You'll have all 3 of those days to work on these problems and see me if you have questions. And our quizzes will be next Thursday. We'll have a brief Zoom that day, or I might postpone it. I'll let you know. But our quizzes will be the 17th. That's where you'll take online quizzes, and I'll ask you questions about these problems. So your grade from this, from working these out, is going to come from the quizzes next Thursday, September 17th. So back to the first slide. This chapter is about graphing a little bit and writing equations of lines. It's really a really good ACT review. So if you can remember when I did the chapter 1 overview, I said it's 2 reasons. 3. It's their skills we'll use in Algebra 3. It's on the ACT if you're taking that. And one of the major reasons is it's part of Math 150, College Algebra. It's the same reasons for this one also. This is part of Math 150. My students in that class will have to be able to do these things. This is really good ACT because it's actually considered some geometry with this, or part of this is considered geometry, I think. And then we'll use some of these skills in Algebra 3. So graphing. I still can't see the colors from where I'm standing looking at the board. So I have to walk over to my desktop to make sure the colors are matching, which is really important with these lines being in different colors. So if you could tell I'm moving around, that's why. So I'm going to graph the y equals 2x plus 5. So little review. This is in slope-intercept form, the 2x plus 5. This is the y-intercept. And it looks like we're having some tech issues here. That's the y, 5 is the y-intercept, and 2 is the slope. This weird writing is not me, it's I don't know what's wrong, something's going on here. But anyway, so if we graph y equals 2x plus 5, on the y-axis, we'll go up to 5 to plot the y-intercept. So right here. And then from there, we'll count off a slope of 2. So remember that slope is rise over run. So if the slope is 2, I'm going to go up 2 over 1. Now I'm going to erase that, so if you need to jot that down or go back and watch it, do so, or take a screenshot. But from 5 on the y-intercept, I'm going to get some other points incorporating the slope. So the slope is 2, so I'm going to go up 2 over 1. If the slope is positive, the line should be rising. So I'm going to go up 2 over 1, up 2 over 1. And the same pattern I don't want to go up 2 over 1. I don't want to do that. It's the same pattern. So it's down 2, left 1, down 2, left 1, and that's plenty. I mean, you can get some more if you'd like. 3 or 4 points is sufficient. But so it'll form a straight line. If you get a crooked line, you've made a mistake. So I have a straight line through there with arrows on both ends. And so this would be y equals 2x plus 5. So you should be able to look at a line in slope-intercept form and know the slope, the y-intercept. Know that if the slope is positive, the line is rising from left to right. The other line is x equals 4. So that one will be in green. X equals a number is always a vertical line. The slope is undefined for every vertical line. So to graph it, we'll go over up to the x-axis and find where x equals 4 and just draw a vertical line right through there. Every point on this line that I just drew, the green line, if we were to list ordered pairs, like this point right here is 4, 2. This point right here is 4, negative 4. What has to be true about every point on this green line is that x equals 4. So every ordered pair on that line, there are an infinite number of points, an infinite number of ordered pairs, but for every single one of them, the x value is 4. That would be the entire domain. We're not going to talk much about domain or range yet, but just to start to even hit on that, that would be the entire domain, where the range goes from negative to positive infinity. So we've done one slanted line. That was the first one that I did in red. Slope-intercept form, slope is positive, line is rising. And we did one vertical line. X equals a number, you'll just have to know and have memorized. X equals a number is a vertical line. The slope is always undefined for any vertical line. Continuing to a couple of other graphs. Y equals 3. I'm trying to use the same colors, and I can't even tell exactly what color that is, so I'm going to go with this color. But so for y equals 3, y equals a number is always a horizontal line. And again, this is dragging, so I'll try to write more slowly. For every horizontal line, the slope is always 0. If you all were sitting in here, I would be asking you, and hopefully someone would remember. So for y equals 3, we would go on the y-axis to 3 and draw a horizontal line. That's ugly, but y equals 3. So just like I said on the previous slide, if you were to pick a point, like right here, the ordered pair is 4, 3. If we were to pick this point, the ordered pair is -9, 3. What has to be true about every point on this line is that y equals 3, and it is. So the domain, all of the x's are infinite, negative to positive infinity, forever left and forever right. But the y value is constantly 3, is always 3. So this line that I just drew matches the equation y equals 3. It's flat, it's straight, and its slope is 0. For the line underneath it, that is in standard form. So what we will need to do in order to graph it is to solve for y. And I'm sure you know how to do it, and that everyone in their lesson last week, where we solved some equations for different variables, we're going to use that now. So that's why I'm sure everyone knows how to do it and tried all of them and asked me questions if they didn't. So we want to take this equation and solve it for y so that it's in slope-intercept form, like the equation we graphed on the last screen. So I'm going to subtract 4x from both sides. Actually, I'm gonna add 4x to both sides. So you wouldn't normally have that plus there. I know that looks silly, but I added 4x to both sides. Now we would divide everything by 3. I mean, you don't have to write 3 this many times, but I want to emphasize that everything is getting divided by 3 in order to isolate y. So if we divide by 3, we'll have 4/3 x, and do pop that fraction out front so it's clearly the coefficient. Don't have it like this. It's not wrong, but it's just easier to say like, okay, this is the m value. 4/3 is clearly sitting there in front of the x when you write it this way, as opposed to this way. So don't write it that way, even though it's not wrong. That's just more obviously gives you the slope, and it's going to be in slope-intercept form, which I am specifically asking for. And then 12 divided by 3 is 4. So we added 4x to both sides, divided the equation by 3, and so now we have the equation in slope-intercept form. So the y-intercept is 4, and the slope is 4/3. So slope is rise over run. So we're going to rise 4 and go over 3. Now the slope is still positive, so the line will be rising. So I'm going to go up 4 and over 3. And I can only fit in 1 point on the right side, so that's all I'm going to do. On the other side, I'm going to go down 4 and left 3. Down 4 more and left 3. Hopefully I counted correctly. You can't see me, but that's what I'm doing right now. And so here is our line. Hopefully everything's color-coded to match. So you should be able to graph any horizontal, vertical, or slanted straight line. You should be able to identify the slope and the y-intercept from the equation. A little recap, even though you can go back on your own. The y equals 2x plus 5. The slope is 2, y-intercept is 5. X equals 4 is a vertical line, so the slope is undefined, and it didn't have a y-intercept. It never crossed the y-axis. On the second slide, y equals 3 is horizontal, so the slope is 0. It does have a y-intercept though. It crosses at 3 because y is always 3. And then the last equation, we had to rewrite into slope-intercept form. So the y-intercept is 4 and the slope is 4/3. The slope is positive, so this line is also rising. We're still going to work with slopes and points and equations and stuff. We'll be writing equations and finding slopes in a second, but now we're just going to convert to a different type of notation. So this is just going over what function notation is and evaluating a function, a fairly simple function actually. But I do have some people sometimes come into Algebra 3 and think that that means f times 3, and that f is a variable. So this is just function notation. This is no different than if I wrote y equals 6x squared plus 4. So you would read that f of x. F is a function of x. So if we're looking right here, this is asking us to evaluate the function above at 3. Notice where there was an x, there is now a 3. So we're going to plug in a 3 every place we see an x. If there was more than one x, we would plug it in more than once. So for f of 3. So f of 3 means we're going to take the function f and plug in 3 for x. You can use a calculator, you can do this in your head. 3 squared is 9 times 6 is 54. So we end up with 58. Again, you don't have to show work like right here, because I know you might be using a calculator there. F of -4 is saying to evaluate f is the function, it's a function of x. This right here is clearly saying x equals -4. So we're going to plug in -4 everywhere we see an x in the function. So 6 times -4 squared plus 4. Now, note, the negative is getting squared. So a negative times a negative is a positive. So this is a positive 16, not a negative. If you type this into your calculator right here, the calculator knows the order of operations, and it will do exponents before multiplying by -1. I'm going to say that again, or you might want to run it back. This is a common mistake whenever I've taught when I've taught pre-calculus, college algebra, and of course algebra 3. Now, normally I just have to mention it once to somebody and they got it. In the college algebra pre-calc course, we have a little bit more trouble with this in here, but not too much. So first, we're plugging in -4 for x. So the negative is getting squared because x is getting squared. So a negative squared, and negative times a negative is a positive. So if you were going to type this into your calculator, you would have to have the negative in parentheses. That'll mess you up if you don't. Anytime this exponent is not just 2, but even. So you have to have the negative in parentheses because the negative is getting raised to that power. If you don't, I do want you to know what's happening. If you type this in, the calculator knows the order of operations. Parentheses, exponents. It'll square first, and it considers this multiplication. So it would square first and say, this is 16, multiply by -1, it's -16. You'll get the wrong answer every time. There's an even exponent. So, in other words, -4 squared is positive 16. That's what, 96 plus 4 is 100, I hope. You can't see me, but I'm using the calculator to double check. Yes. So that's a quick review of function notation and what it means to evaluate a function at a certain number, at an input value. Couple more. So you've got g of x on the left. This is kind of driving home that same point. So determine g of -3. So g of -3, I'm going to plug in a -3. That's getting squared. And negative squared is positive. 9 plus 5 is 14. And you're welcome to just type this into your calculator, what I boxed in, and it will tell you it's 14, but you do have to use the parentheses. H of 5. So notice the differences. The 5 is positive, but we have a negative in front of the x squared. So 5 is getting squared, but not the negative. The x is getting squared, and then the opposite is being taken. So this is very different. So this is actually -25. So the final answer is -29. So note the difference between those two. Here, the negative is getting squared because the negative is the input value, and x is getting squared, the input value. On the right side, only x is getting squared. If the negative is getting squared, it'd have to be written like that. So it's not. The input value is 5, so 5 is getting squared, but not the negative. Continuing to slope. I'm not sure, something has happened here. I'm gonna see what you guys can see. Okay, so I can't see what's in that banner where it says find the slopes of the lines between pairs of points unless I come to my desktop. I am going to change this color, hopefully quickly, to black. Nope. So those delta y's and delta x's are still showing up yellow. I hope you can see that okay. But this is saying slope is change in y over change in x. Also called delta y over delta x. Delta in mathematics and engineering and physics, delta indicates change. So I'll just draw it down here. So delta y over delta x is also a way to write slope. And then I put up the formula, which again, that's just change in y over change in x. But if you like to use those subscripts, y sub 2 minus y sub 1, that's kind of how we think of slope when we're finding the slope between 2 points, which is what we're doing here. So if you're graphing, it's nice to think of slope as rise over run, or change in y over change in x, vertical change over horizontal. If you're finding the slope between 2 points, the formula is best. So we're going to find the slope between the one on the far left. So m equals, so take any y. So 5 minus 1, that would be change in y. Since I started with 5, I have to start with the x that comes from that point. I have to start with -3, I can't start with 2. So change in y over change in x. The most common mistake is people putting x on top and y on the bottom. So we have 4 over -5, or even better, move that negative up top since we read top to bottom. -4 fifths. Also worth mentioning is that means the line would be falling. I think on your assignment, when you find the slope, you have to state if the line is rising, falling, or flat. So since the slope is negative, this line is falling. Okay, on to the one in the middle. The 6, 5, 8, 5. I'm going to switch colors to keep it distinct. So m equals change in y over change in x. 5 minus 5 is 0. 6 minus 8, 0 over any number is 0. So the slope is 0. So you should know that means that line is horizontal. If we plotted those 2 points and drew a line between the two, it would be a flat horizontal line. So if you're asked if the line's rising, falling, or neither, it's neither rising nor falling, or you could say it's flat. And then the last one, slope equals change in y, so 8 minus -3. Notice that, 8 minus a negative, you're adding. And then 2 minus 2. 11 over 0. 0 in the denominator, whether you're finding slope in Algebra 1, limits in calculus, no matter what you're doing, 0 in the denominator is always undefined. Now you should know from me a few minutes ago and from previous classes that an undefined slope means the line is vertical. If we plotted these 2 points and drew a line in between them, we would have a vertical line. So the one on the left is falling, the one in the middle is flat, and the one on the right, the slope is undefined and the line is vertical. So you should know various definitions for slope. You should know the slope formula and be able to use it. You should also be able to describe slope as rise over run to help you with graphing, or as vertical change over horizontal change. So now we're going to write the equation of a few different lines given different pieces of information. I want every time your final answer to be in slope-intercept form. You might start with point slope. I think I have that on one of the slides. Well, I did. I might have lost it somehow. Oh, there it's at the bottom here. Okay. Well, so it says you're welcome to start with point slope form if you remember it from Algebra 1. I don't know if you use it in geometry or not. But I want your final answers always in slope-intercept form unless I indicate otherwise. So I'm also going to work from the beginning with slope-intercept form. So to write the equation of a line, we need 2 things. We need the slope, and we need the y-intercept. For this particular scenario, we're given the slope. We need to find the y-intercept. So if we were to start writing this equation, we know that it's going to be y equals -1/2 x We just don't know what to put here just yet. So we do know a few things though. We know the slope is -1/2, and we know that when x is 2, y has to be 3. So then we're left with one unknown, that being b, or the y-intercept. So you solve this equation. So the 2's happen to cancel out. We'd add 1 to both sides, and we get that the y-intercept is 4. So that will be the y-intercept. You should be able to graph it if you needed to. You should be able to match it to a graph if that was on the ACT. So I'm going to go over to the right side here. That's not a question mark anymore. This is the answer to the question in slope-intercept form. Again, you can start with point slope if you like. It's just as easy, maybe even a little easier sometimes if you're more comfortable with the distributive property. But your final answer needs to be in slope-intercept form. That's not me just trying to be difficult and make your life harder. Normally you see them on whether they're standardized tests or my test, they're in slope-intercept form because they convert more easily to graphing. That's probably the main reason, which also means you could type it into your graphing calculator and graph it that way. This line, by the way, would be falling because the slope is negative. Same scenario, just different information given. I think different information. Yes, it is. So now we're given neither the slope nor the y-intercept. We still need the same two things. We still need slope and the y-intercept. But for this problem, we're given neither. However, we're told that the line we're writing an equation of has to be parallel to this line. Well, what's the slope of that line? You should know that that line's slope is -3. So if the slope of that line is -3, and we're writing the equation of a line parallel to it, the slope has to be the same. So I'll just make a note here. I normally probably wouldn't be, and I have a feeling these colors aren't matching, and they should be. So parallel, same slope. Remember, perpendicular is opposite reciprocal. I'm probably doing that one next. So the slope of our new line is going to be -3. And it contains 3, too. So just like the last slide, let's use slope-intercept form. I like to write it because it gives us a little place to look at, like what goes where. So the slope is -3. Again, it's the same because the lines are parallel. And we know that when x is 3, y has to be 2. We know that from the ordered pair. So we know the slope. I just put a check mark there. We can solve this equation. -3 times 3, add 9 to both sides. Now we know the y-intercept. So what's the equation? Y equals -3x plus 11. If we plugged in 3 and 2, we should get a true statement. Or, said another way, if I plug in 3 right here, I had better get 2 for y, because right here, it says that 3, 2 should fit that equation. That's a good way to check your work without going back and looking at every little step. Sometimes if you made the mistake, you don't see it yourself, but you could take this equation right here, plug in 3 for x, crunch the numbers, you should get 2 for y. So parallel lines have the same slope. Write the equation of a line passing through a point. Use slope-intercept form. Write your final answer also in slope-intercept form. Another scenario still. Now we're given 2 different points. Well, what can we find with 2 points? We can find the slope, because we still need the same 2 things. We still need slope and the y-intercept. We're given neither, but we are given enough information to find the slope. So the slope is change in y. I'm going to do 4 minus -1. Since I started with 4, I have to start with 3. So 3 minus -2, I get 5/5, which is 1. So the slope is 1. Now use either point. It doesn't matter which one. I'm going to use 3, 4, but it doesn't matter. I'm not going to write that down and take up space with that. You could use either point. So you can imagine if one of the points has a lot of fractions or negatives or large or small numbers, you might pick a more user-friendly ordered pair. So I'm going to use 3, 4. So once again, I'm using y equals mx plus b. I know that my slope is 1 when x is 3, y is 4. So 4 equals 3 plus b. If I subtract 3 from both sides, I get that b is 1. I got going kind of quickly there with that algebra, so you might want to roll that back and see it. But we were given 2 points, so we found the slope. Once we had the slope, we used one of the points to plug into slope-intercept form with that slope we just found to then find the y-intercept. So now we have the slope and the y-intercept. So the equation is y equals 1x plus 1, or just x plus 1, even better. So that was the end. Here are the 4 sections I'll have you look from. I will post the pages, and I'll make sure I post them so that the numbers are clearly showing. But remember to label your work using the section number and the page number. There is some graphing with these because, we graphed a little bit. If you have graph paper, great. If you don't, you can maybe print some off. There's free graph paper sources on the internet. Or just do your best to use lined paper and be as neat as possible. Here are the solutions. I'm going to scroll through these slowly, but the best place to probably view these is of the PDF version of these flip charts. So there's 2.1 and 2.2. 2.3 is just one question. I think it's a couple different parts, graphing and writing an equation. So that line should be falling. Might look like it's falling kind of steeply and have a y-intercept at 8. And then there's 2.4. I believe that's it. Yes. So remember, this video is for Thursday and Friday, and you start those problems Monday or early if you want to, and you should wrap them up on Wednesday. They should be completed and corrected, so you'd be contacting me the first half of next week with questions over these, or Thursday or Friday. You can start early, like I said. And the quizzes will be next Thursday, September 17th.